Hello, ever wonder how rockets propel spacecraft? In this video, I'll explain the concept and then show you how to calculate the mass of fuel required for your space mission. When mass is expelled in one direction, there will be an equal reaction in the opposite direction. This is best experienced when you shoot a gun and feel the recoil. The bullet is expelled in one direction and the gun recoils in the opposite direction. The magnitude of the reaction in the opposite direction is dependent on the mass being expelled and its velocity. Larger mass and higher velocities produce more reaction, therefore, higher velocity in the opposite direction. The equation that relates the expelled mass and velocity to the spacecraft's resulting change in velocity, or delta V, is called the rocket equation and is shown on my right. It can be derived using the concept of conservation of momentum and was independently derived by several people. However, it is generally credited to Konstantin Tsiolkovsky, who published it in 1903. In this equation, ln is the natural logarithm function, Vex is the gas exhaust velocity, mi is the initial mass of the spacecraft, and mf is the final mass of the spacecraft after the rocket burn. In other words, mi includes the mass of propellant expelled, but mf does not. If you want to know the mass of fuel required to get a particular change in velocity, you can use the following equation, which is derived from the previous rocket equation. This equation is especially useful when using our satellite orbit simulator to design space missions, since SOS gives you the required delta V. You simply need to know the initial mass of the spacecraft and the rocket's exhaust velocity. Higher exhaust velocities make rocket motors or rocket engines more efficient. Typically, rocket efficiency is described using specific impulse, or ISP, which is defined as the average exhaust velocity divided by the acceleration due to gravity at sea level. I show this in the new equation on my right. The units for ISP are seconds. A typical value for chemical rockets is about 300 seconds, and higher values are better. If you found this video useful, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We also need your feedback, so please leave comments. Goodbye.